All right, so today all I'm going to do is review. I'll take whatever questions you have off the review, answer however many you need, as well as show you the formula sheet that you'll get. But let me remind you that this Friday is the end of the 9 weeks. All grades have to be in by Friday. If grades aren't in by Friday, it's a 0. There are no incompletes this 9 weeks. You have to turn it in by Friday, otherwise it's a 0. I don't know how many different ways I can say that. If it's not turned in by Friday, it's a 0. There's no late work after Friday. All right? Get it in by Friday, or else it's a 0. I don't know how to make that any more clear. All right, enough of that. Again, most of you guys are fine. Most of you guys at home are fine. There's just a few people that still have some stuff to do. This is the formula sheet that you'll get on test day, which is tomorrow. It's like, whoa, that sneaks up on us. So I see a sum. I see some differences. I see some halves. What's not on there? The doubles. Okay. Are you going to memorize the doubles, or are you going to use what's given to figure out the doubles?
Use what's given.
Well, I heard both answers, and both answers are fine. Either answer is okay. Let me just take a minute to show you that if you're going to use if you're memorizing, fine. If you're going to figure it out, then how you do that is put in x for both pieces. Sine x, cosine x, plus cosine x, sine x is 2 sine x, cosine x. So there's how you figure it out if you want to use the figure it out method. Same thing with cosine, but you'd end up with cosine squared minus sine squared. So I leave it up to you, and the response was split. You can memorize the doubles, or you can use the formula sheet to figure them out. Either way, or both. Check your work. Either one. Okay. The real reason we're here today is for me to work some review questions. Hopefully you've done a chunk of these. Hopefully you spent some time Friday doing these, or over the weekend, but hopefully just Friday. What questions from the review do you have? Number 4. Using a sum or difference identity, find the exact value of tangent of 11 pi over 12. Sum or difference. So I've got to add or subtract to get to 11 over 12. Probably the best way is to add. If I subtract, that's fine, but I'll have bigger numbers, so I'm going to try to add to get to 11 over 12. Let's see, so my denominator's 12. I need to pick things that reduce, right? Because I don't know anything about pi over 12 or 5 pi over 12. And what am I trying to avoid if I really want to go next level here? I really do not want to use pi over 6, so I don't want to use 2 over 12. So let's see, 7 and 4, let me grab a pencil, but 7 doesn't reduce. So yes, 7 plus 4 is 11, but 7 doesn't reduce. 8 and 3 definitely makes 11, and they both reduce. So 2 pi over 3 plus pi over 4. All right, so now it's yeah. Why are you even talking about calculators? You don't have a calculator on this unit anyway.
I know, in the last week.
So I go to my sum formula for tangent. Tangent of the first one plus tangent of the second one over 1 minus tangent of the first times tangent of the second. So people mess that up and put a different something in there. Again, that's just from the formula, which you'll have next to you. Okay, now for the fun part of the tangent one is the algebra stuff that comes next. Like The pre-cal part is easy. Like, we're done with pre-cal. The hard part is what adds to 11 and reduces the right way. And then how do I handle all of this?
First off, just
Let's see. Tangent of 2 pi over 3 is negative root 3. Tangent of pi over 4 is 1. Over 1 minus negative root 3 times 1. So negative root 3 plus 1 over 1 plus root 3. Right? Because the two negatives make a positive when we're multiplying. So that's not any of my answers, though. What do I need to do to fix that? Multiply by, the fancy word you're looking for is conjugate. Multiply by the conjugate of the bottom. Write small and zoom in. So, FOIL the top. First, outside, inside, last. Again, I hope you can FOIL that quickly, otherwise you're going to get bogged down. Multiply the first, multiply the outsides, multiply the insides, multiply the last. I'm going to clean up the top while I'm here. So negative 2 root 3 plus 4. And then FOIL the bottom. First. Oh, when I FOIL the bottom, what happens when I... Yeah, the O and the I of FOIL go away in the denominator. So 1 minus 3 is negative 2. Now, which of those top pieces am I going to divide by negative 2? All of them. It's all over negative 2. Please make sure you divide all of it by negative 2. Root 3 minus 2 is my answer. Naturally, none of them are written exactly like that, but I need the 2 to be negative and the root 3 to be positive, so yes, A. Answer choice A. Alright, I definitely wanted to do a tangent one because of the algebra. In fact, most of this test is like, how's your algebra? Because we give you the formula. So can you handle the fractions and square roots? Number 10. Which one?
10 or 7.
10's a double and 17's a half, so let's do both.
Okay.
That way we'll hit a little bit of everything. Number 10. If tangent of x equals negative 2, and x is between 3 pi over 2 and 2 pi. So I know where to put the picture. In the fourth quadrant. Tangent is opposite over adjacent, but I only have one number there, so how do I turn that into an opposite over adjacent situation? Yeah, just put it over 1. So opposite is negative 2, adjacent is 1. And is this the famous 1, 2, 3 right triangle?
It is.
No, because there is no such thing. One plus 4 is 5, so it's the less famous 1, 2, square root of 5 right triangle. Far less famous. Alright, now I'm ready to answer my questions. Sine of 2x, either from memory or from the formula sheet with a little bit of work, is 2 sine x cosine x. So sine of x, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And again, it's not the sine of negative 2 over root 5. It's not the cosine of 1 over root 5. The sine is equal to negative 2 over root 5. So do not write sine of this. It's the sine of x, which is this. It seems minor, but people get messed up when they don't replace sine. They only replace the x. So I multiply across, and it turns out I don't need to fix the bottom, because root 5 times root 5 is just 5, and so it looked like it might need a fix, but it turned out I didn't. Cosine of 2x. Let's see, either by memory or by formula chart after you fill it in. Cosine squared minus sine squared. So cosine is still adjacent over hypotenuse squared minus opposite over hypotenuse squared. I feel like this whole unit, the pre-cal really isn't the issue. It's the algebra after the fact. So root 5 squared is 5 minus negative 2 squared is 4. Root 5 squared is still 5. And that works out kind of nice because there's a common denominator already there for me. Negative 3/5. Tangent of 2x. Two ways to do this. I can use the formula to come up with tangent of 2x, but there's an easier way. What was one of the first things? We can use both of those because what's tangent equal to? Y over x, or sine over cosine. And then it's going to work out really well even for simplifying. Negative 4/5 over negative 3/5. Either there's like 3 different ways to go here. You can see that the 5's reduce and call it 4/3. You can say you want to multiply the top and bottom by 5 to cancel out the 5's. Or you can keep it, change it, flip it. But whichever of those methods you use, hopefully you land at 4/3.
On sine, the second step, doesn't the 2 go to the negative 2 and the 1?
No, common mistake. When you're multiplying numbers, 5 times 3 times 2, you don't do 5 times 3 and 5 times 2. Right? You do 5 times 3 times 2. But that is a common mistake because it looks like maybe I should distribute the 2, but you're not distributing the 2. It's just multiply them all together. Right? Like the same with adding. You don't, if it's 5 plus 3 plus 2, you don't do 5 plus the 3 and 5 plus the 2. You just add up the numbers. But I'm glad you asked that because someone's probably still going to make that mistake and distribute that too. It won't be Will. I'd bet money it won't be Will.
Thank you. I appreciate the compliment.
Number 17. A half angle formula. Sine of x equals 2/3 and x terminates in quadrant 2. Okay, so x is in quadrant 2. Sine is opposite over hypotenuse. Opposite over hypotenuse. show all work neatly. There's another good place to take off a point if I'm really feeling neatly. Very subjective grading.
Will.
Yes, I could
Well,
get
it's not the
I could get some of you on that every test,
It's just showing
every
work
problem.
is what Will's issue is.
Well, you can
That's
talk
right.
about
Show
stuff
all
like
work.
that.
Some people have enough problem with that, and then neatly is just a step too far for a
This is-
few.
This is bullshit.
A 2-3. Let's see. What side is that? The famous 1-2-3 right triangle? No, because there is no famous 1-2-3 right triangle. It's the less famous. Yeah, root 9 minus 4 is 5. 2 root 5 3 right triangle. Significantly less famous than 3 4 5. What is the value of tangent of half x? Well, the formula is 1 minus cosine x over sine x. Oh, and the nice thing about the tangent is I don't have to worry about the plus or minus thing. Right? Sine and cosine, you got to pick the right sign. Tangent, it works out on its own. Since we're here, let's pick the right quadrant anyway, just to kind of verify our answer. If x is in quadrant 2, where is x over 2? So if x over 2 is in quadrant 1, the tangent should be positive. So I should have a positive answer here. We'll see if that happens. If it doesn't, then I did something wrong. 1 minus, let's see, the cosine is adjacent. In my joking around, I almost made a mistake. I guess I did make a mistake. I just caught the mistake. What's not right about my picture? No, the root 5 is not the hypotenuse, right? Because opposite hypotenuse. But it's negative because it's backwards. It's going to the left. All over sine of x, which is 2/3. From here, I can't cancel those 3's. I'm not going to say that. Some people are going to get a common denominator. I have a student in 4th period who will not do what I do, which is fine. She always wants to get a common denominator and do keep it, change it, flip it, which is fine. What I've been doing is sort of clearing the denominators, so I don't have any denominators to worry about. So I'm going to multiply the top by 3 and the bottom by 3. 3 plus root 5 over 2. I don't know what that is, but I know it's positive, so I feel good about that answer. For my 4th period student who likes to keep it, change it, flip it, you'd have to get a common denominator in the top, and then you would keep it, change it, flip it, and sure enough you get the same thing. So she's committed to keep it, change it, flip it. I feel like clearing denominators is easier, but it's the same thing, whichever way.
Are you 16?
Yes, because we need to pick the right quadrant for 16. All right, cosine's 4/5. X is in quadrant 4. So adjacent over hypotenuse. Adjacent over hypotenuse. Oh, finally we get a triangle that we like. A famous one. What's the missing side on this one? -3. Good. -3. Okay, part B. Cosine of x over 2. You know what? Let's think about quadrants here. If x is in quadrant 2, or quadrant 4, then x over 2 is in quadrant 2. All right, this is the little trick that you just divide the quadrant number by 2 and round if you need to. So in quadrant 2, is cosine positive or negative? Negative. So I can rule out A right away. Sine's going to be positive. Well, they're all positive, so that doesn't really help. Tangent in quadrant 2 is negative. Rule out one of those guys. Alright, but the formula, plus or minus, not both, you got to pick one. Check my formula sheet. 1 plus cosine x over 2. I've already picked, I know it's negative, so I can keep writing the negative there. 1 plus 4/5 over 2. And again, you have options on how you want to clean that up. I'm just going to multiply the top and the bottom by 5. So I get 5 plus 4 all over 10. Because I distribute the 5 to the 1, I get 5. 5 to the 4/5, the 5's cancel. That's why we multiplied by 5, to get rid of that denominator. So negative square root of 9/10, which isn't one of my answers because I can clean this up a little bit. Square root of 9 has an answer. And then when we fix it, negative 3 root 10 over 10. So the answer to question B is letter C. I'm worried not for the pre-cal, but for the algebra. I guess I've said that a couple times. But the keep it, change it, flip it, fraction stuff, finding missing sides, like stuff that's not supposed to be hard, but lots of places to make a mistake. Put it that way. Other questions? So we've done a sum, we've done a double, we've done a half, and several halves. So we've done one of everything. Anything else stick out to you? Ooh, number 9. Well, there's something with a double or a half going on, so I'm pretty sure it's either A or C. Sine squared plus cosine squared would be 1. But this is minus, so I don't think it's 1. And I don't think it's 6x. I think that argument's going to change. So I got to figure out which way is the change going here. Let's see. Cosine of 2x is cosine squared of x minus sine squared of x. So if I match this up, it's like 6x is going there. It's like 6x is in the place of x. So does that mean the right-hand side is 3x, or the left-hand side is 3x or 12x? This is weird, but I'm replacing x with 6x. I'm replacing x with 6x, so it's 12x. That's a tricky one. But hopefully you could get it down to 50-50, because it's not 1 and it's not 6x. It's just, what are we doing with the 2 here? we only did one sum and identity, and it was a tangent one. No, tangent's the hardest one, so that makes sense. And you might remember there's sort of two types of sum and difference ones. There's one with unit circle, 2, 3, and 4, and then ones that are picture problems like number 5 and 6 and 7. Questions, comments, concerns?